All right, we're going to start talking about dilations. And there's two types of dilations. There's enlargements and reductions. And it sounds just like what it is. Enlargement means it gets bigger. Reduction means it gets smaller. So we're going to start with an enlargement. So the new figure is larger than the old one. The difference is when you do a dilation, the figure has the same angles in it, but it has different side lengths. So the new figure is proportional to the old figure because it meets the definition of a proportion. And the new one should look like the old one, just bigger or smaller. When you do an enlargement, the scale factor is greater than 1. Just a vocabulary, the pre-image of ABC comes first. The image, which is A prime, B prime, C prime, that always comes second. And the primes help you know which vertices match up with which vertices. Okay, so our first example, find the center of dilation and the scale factor of the enlargement. Okay, so to find the center of dilation, you're going to want to take a ruler and you're going to want to draw a line from, or through, I should say, corresponding vertices. So I'm going to draw a line through C prime and C. And then you're going to draw a line through another pair of vertices, being as exact as possible. And what you'll see is your lines are crossing each other. In fact, if you do the third line, which is A to A prime, all three lines cross at the same point. So the point at which they cross is the center of dilation. So in this case, the center of dilation is 0, 0, or the origin. So that's the first thing you're supposed to find is the center of dilation. Okay, so the second thing you're supposed to find is the scale factor of the enlargement. Okay, so a scale factor is equal to a new length, and I'll put a prime on that just to remind you, a new side length over an old side length. Now, the easiest way to do this is to find sides that are horizontal or vertical so you don't have to do distance formula. You can just count the spaces and you've got the length. So for these two triangles, A to C and A prime to C prime are both horizontal lengths, so I can just count them. A prime to C prime is 1, 2, 3, 4 spaces, and A to C is 2 spaces. So putting the new length over the old length, I get 4 over 2, which is a scale factor of 2. That's the easiest way to get it. Now, if there aren't any horizontal or vertical sides you can count, then we are stuck using distance formula. So if you chose to find the length of side OC and compare it to the length of side OC prime, that's at an angle, and you'd have to use your distance formula. So I'm just going to give you what it would be. For the OC, it would be 3 minus 0 squared plus 1 minus 0 squared. And then you'd have to simplify it, and you would get square root 10. So that's O to C. O, by the way, is the origin. So then I can compare that to O to C prime, which would be 6 minus 0 squared plus 2 minus 0 squared, and it ends up being radical 10. So for the distance formula, you can do sides, or you can do the distance to the origin. the center of dilation. This one, obviously, OC prime, I did distance from the vertex to the origin and from the vertex to the origin. But I could have also done A to B and A prime to B prime, or I could have done B to C and B prime to C prime. Any two comparable lengths are free game. All right, example number 2. Draw an enlargement with the scale factor of 2 and a center of dilation at 0, 0. Okay. There are two methods. Method number 1 is you're going to multiply the coordinates by the scale factor. This works if you have a center of dilation at 0, 0. That's probably the shortest way to do it. And so I'll show you what this looks like. Let's say you've got point A, which is 2, 3. So for A prime, you're going to multiply 2 times 2 and 2 times 3, which means A prime is at 4, 6. So you just multiply by the scale factor. And again, this only works if your center of dilation is the origin, which it commonly is. To do B, let's say B is is positive 2, negative 2. So B prime would be 2 times 2 and 2 times negative 2, which is 4, negative 4. And we'll do the last one. C is negative 1, negative 4. To find C prime, you multiply them both by 2. So 2 times a negative 1, 2 times a negative 4 means that C prime is negative 2, negative 8. That's method number 1. Multiply by the scale factor. All right, method number 2. Method number 2 is to count the squares on the spokes, and I'll show you what that is in a second. Count the squares on the spokes. All right, so take your ruler, and the origin is our center of dilation. So I want you to draw a line from the origin through each of the 3 vertices and extend them beyond the vertices quite a way. So make a spoke. And then from 0, 0 through B, and then 0, 0 through C. Those are your 3 spokes. And I'm going to color this little triangle so you can see it. Okay, so the second way to draw an enlargement, which is graphically, is to count the squares. So what do I mean by that? Well, if you start at 0, 0, to get from 0, 0 to A, I go up 3, 1, 2, 3, and over 2. So up 3 and over 2. So that means if I want to double the side length, so my enlargement is by a factor of 2, all I need to do is double this length. So up 3, 1, 2, 3, and over 2. Mine is a bit of a near miss because it's hard to be exact. But yeah, this would be your A prime, which if you look is 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5, 6 up. So do that on your spokes. Count to go to B, we go 2 to the right, 2 down. So then go 2 to the right, 2 down. Draw your B prime. Just 4, negative 4. And same thing with the C. 1 left, 1, 2, 3, 4 down. 1 left, 1, 2, 3, 4 down. BC prime, negative 2, negative 8. If you connect your 3 new vertices, you should get a triangle that is the same shape as the original one, just twice as big. If you're dealing with really weird distances, here's a trick you can use. You can use your compass to measure from the point of dilation to the original, and then pick it up and measure it again and make a mark. So you can also do it using a compass, which I oftentimes do.
That one seems easier.
Yeah, I prefer the compass. It's fast, but both ways work. All right, flip the page. All right, now we're going to do dilation as a reduction. Reduction means to make it smaller. So dilation as a reduction. If it is a reduction, the scale factor is less than 1. That's how you can tell it's a reduction. So we're going to find the center of dilation and the scale factor of the reduction that's shown. So take your ruler. Now, because the new figure is inside the old one, you don't have to extend the lines as far out, but do draw a line from C to C prime and then towards the middle. Do the same for B. Draw a line B to B prime to the middle. And the same thing for A to A prime to the middle. Where the three lines cross each other is the center of dilation. Which ends up being 0, 0. All right, so the scale factor, the formula is the same. It is still a new length over an old length. And again, if you can count the squares, it's much easier than doing distance formula. So I'm going to use the count the squares. My new side, C prime, B prime is here. That is 3 squares. My old CB is here. 1, 2, 3, 4, 5, 6. That is 6 squares. That's the old one. And 3 over 6 equals 1/2, which is definitely less than 1. So it is a scale factor for reduction. Again, you can pick any 2 sides, or you can pick the origin through a point. So you could choose OC and OC prime and use distance formula, which I'm not going to go over because I went over that on the front page. Okay, example 2. Draw the reduction with a scale factor of 1/3 and a center of dilation at 1, 2. All right, so this one's different. The center of dilation is not at the origin, so some of our stuff won't actually work. First thing you want to do, because you want to know where to position the points, your new A prime, B prime, C prime will be, again, each of them will be on their own little spoke through the old point and the center of dilation. Okay, so how do you find the scale factor of 1/3 if the center of dilation is not at the origin? Okay, so what you're going to need to find is the distances to the center of dilation. Yes. So what are our distances? From 0, or from the center of dilation to A, I'll put a little subscript A, 1, 2, 3, 4, 5, 6, distance equals 6. The distance to B is 3. The distance to C is 6 again. And the distance to D is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is 9. So find the distances to the center of dilation. And then multiply by the scale factor, which in this case is a third. So I'm going to multiply 6 times a third, 3 times a third, 6 times a third, and 9 times a third. What I get is 2, 1, 2, and 3. Okay, so from the center of dilation to my new distance A is going to be 2. So starting at the center of dilation, count 2 spaces, and that is my A prime. Distance to B, count 1 space, that's B prime. Distance to C, count 2, that's C prime. And distance to 9, count 3. 1, 2, 3. That would be my D prime. And connect. Should be the same size and shape as the original, just a third the size. All right, let's turn the page. And we're going to do some practice problems. Number 1, point A is a vertex of a polygon. Point R is the image of A after the dilation. Find the scale factor of the dilation. Okay, so A is 1, negative 1. That's A. And B is 3, negative 3. 1, 2, 3, 1, 2, 3. And we went from A to B. Now, they don't give you a center of dilation. The default is the origin. All right, so the way you break this down, remember on the first page when you're trying to do a enlargement, you would take the coordinates and multiply them by the scale factor of the enlargement, right? And that made them twice as big. We need to know what to multiply these by. So we're going to take the coordinates of A, which are 1 and negative 1. We're going to multiply the coordinates by n and set it equal to B, which is 3 and negative 3. So we're going to start with the x coordinate. 1 times n equals the x coordinate of B, which is 3. We get n equals 3. Now, if you wanted to double check it, you can do the same to the y coordinate. My y coordinate is negative 1 times n is negative 3. And sure enough, we get n equals 3. So our scale factor is 3. So you just figure out what the original point was multiplied by to get the new point. Okay, number 2, a line segment has the given endpoints. Use the scale factor to write the ordered pairs after the dilation. All right, so A is negative 2, 1. So negative 2, 1 up. B is 3, 1. 1, 2, 3. I'm going to connect those. It's a line segment. And again, your default center of dilation is the origin. And they want the scale factor, which they sometimes represent with a K, to be 2, twice as big. Okay, so take your straight edge, draw a line from the center of dilation through your point carefully, and do the same for the other point. Draw a line through the center of dilation and the point. Now, you can either do this by counting squares, or you can do it mathematically. Either way will work. Let's do it by counting squares just so we practice doing that. So from the center of dilation, which is the origin, for A, we go up 1 to the left 2. And since we're doubling it, we're going to go up 1 to the left 2. So I'm thinking that's going to be my A prime. Let's do the same with B. To get from the center of dilation to B, you go up 1 and to the right 3. So we're doubling this, so go up 1 and to the right 3 again. And that is B prime. There's our new line segment. Now, the new line segment is supposed to be twice as big as the old one. So count the squares. The old one is 1, 2, 3, 4, 5 squares. The new one is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 10 squares. So that one's 10, and this one's 5, which means we did it right. Now, the other way to do it, of course, is to multiply each of the coordinates by the scale factor, which is 2. So negative 2 times 2 and 1 times 2 give us negative 4 comma 2 for A prime. For B prime, we're going to go 3 times 2 and 1 times 2, which is 6 comma 2 for my B prime. And if we take a look at where these are at, 6, 2 and negative 4, 2 agree. All right, last one. These are floating figures, no graph. Determine whether the dilation from A to B is a reduction or an enlargement, and then find the values of the variables. Okay. A to B sure looks like a reduction, but we're supposed to do it mathematically. So what you want to do, we're going from A to B, is you want to pick a side length and see if the side lengths are getting smaller. So I have a side length of 8. Originally, it got multiplied by some number n, and the side length became a 4. Okay, what times 8 is 4? A half. So the original length was multiplied by a half, and that's how we got to 4. Therefore, it is a reduction, and the scale factor is a half. And then we're supposed to find now x and y. So let's find x. We start out with 10. We multiply by the scale factor, which is 1/2, and that gives us 5. So x equals 5. Okay, now y. Y starts with 12, multiply by the scale factor, which is 1/2, and we get 6. So y equals 6. So you just apply the scale factor to the lengths. Any questions about those?